We're up and running. Okay, so let's get into it. A little panic there. Still, of course, wondering what just happened. I really expected today's lecture to be one of the smoothest ones. But anyway, we got a rocky start. So let's see another example of Docker Compose. And this one's I've been really favoring MongoDB and Python. So I want to switch that up and give another example. I had questions in office hours about MySQL, and I could defer to the lecture notes where I showed a MySQL Docker Compose file, but I never went through a full example of that and really showed it working and showed it off. So I have two examples using MySQL. I actually double dipped a little bit here. These are CSE 116 examples. So the CSE 116 in today's lecture, I'll be talking about the code of these, how to get the WebSockets working, and how to build the app itself. For 312, we're looking at the other side of that of how to deploy it, how to get this running on a server, how to run the Docker Compose, and how to use MySQL, all topics that we're not talking about in 116. So one app, but I get to use it for two courses, so I'm kind of happy I get to do that. But let's take a look at this and see how we're going to get a MySQL app up and running with Docker Compose. And if my viewership is really falling off here, so is anybody in chat using MySQL for their team project? Hopefully at least somebody is. If not, the students can still watch the video, I guess, but hopefully at least one person here is using it. We're using Mongo. Thinking about it. You have 2 days. And 2 yeses. Awesome. Okay. That makes me feel a lot better. But mostly leaning on Mongo here. Okay. So a decent split. Okay. So coffee and burgers and Tate Tot, you're hopefully you'll like this. Let's just get into it and talk about what the app is that we're talking about. It's a chat app. I can register. I'll register as Hartloff. No, I'll register as Jesse again. You register with a username, and then you have chat available. This is live. You can go to chat.cc-software.com and check this thing out. So we'll have 2 live chats going on right now. So go there, play with it, make sure it does work as advertised. But it's a regular chat app. Anything you type here, it's going to show up down here. And it should show up on the stream. So let's take a look at how this app is built. And I'll quickly flash the code, though, of course, those are, as I just mentioned. Yes, there we go. The code itself is 116 topics. Let's take a look at the server. This is Scala code and running a WebSocket server in Scala. That Teddy said, of course. Registering without typing anything. Yeah, there's going to be some user experience features that are missing. But for this, we're specifying the host name. And with Docker Compose, this is something I've seen a few times. Sometimes, or possibly all the time, I had to do this quite a bit, is the host name of localhost doesn't map properly inside Docker Compose. Or rather, that's a feature that it just doesn't know what localhost necessarily is. But if we do 0.0.0.0, that's going to listen for connections on any yes, I got him. It's going to listen for connections on any of the host names. And then port 8080 is what we're going to listen to. Start the server, listen for a few messages, listen for registering usernames and posting chat messages. And then the functionality to respond to those messages. So I don't want to focus on the code much here. A little bit, I got to talk about the database. is we're connecting to a MySQL database, named MySQL as the host name, and then /chatting as the database name. Those two pieces of information are important. Not the names themselves, just like a lot of things, not the names themselves, but the consistency of these names. This MySQL right here has to match what I name my container in the Docker Compose file, and this chatting has to match the database name in my Docker Compose file. And then I'm pulling environment variables for the username and password instead of having username and password hard-coded into my the script. Instead of hard-coding these into my code. So I set those environment variables and then access those environment variables. The rest is SQL, inserting, selecting, updating. I'll go right to Docker Compose. So with Docker Compose, I'll come back to this file because there's quite a bit I want to talk about here. But is there such thing as Mongo injection? Not the same way as SQL injection, but I'm not bold enough to say that no, it's not possible. But it's definitely not a big topic like SQL injection is. SQL injection is pretty much synonymous with database injection attacks. Mongo, just the way it's set up, doesn't lend itself quite to the same attack. Where a SQL statement is one big string, where if you concatenate to that string, you can write any SQL code you want. With Mongo, it's working off objects, and it's hard to inject into those objects since it can't just inject any string that you want. But that said, I'm sure there's very sloppy ways that you could set up Mongo. If you're really basically asking for an injection attack, you could probably set it up in a way to open yourself up to them. But if you're using Mongo, just typical usage, you're not going to run into that. So here's a bad example, I guess, is my Docker file with all my environment variables set. So I'm pulling from the MySQL image, and I'm naming my container MySQL. This name right here has to match the host name of my MySQL database when I connect to that database. So if this were MySQL 2 right here, in my code, I would have to connect to the host name MySQL 2. So that has to be consistent right there. I'm setting my passwords. If you want to try to attack me, I mean, this is live on the database, and it's a terrible example because I forgot to change the passwords. I remembered on the Clicker app, so you can't attack that one. And I guess I just won't open the Docker file for that one. But here, I, of course, would change these. Wouldn't matter anyway because I'm showing them on stream to the whole internet. So even if I did change these, it's not like I'm gaining security. So I'm downloading the SQL container, setting these environment variables, and then MySQL, when the container spins up, is going to read these variables and set the database name. The default database is going to be chatting, and that has to match my URL. When I connect, I have to connect to the chatting database. The root password, which I'm not using for this application, and a username and a password, these I am using. And then for my app, I'm setting environment variables for my SQL username and password, and these are the ones that I'm reading from my code. So when I set up the MySQL database, if you install MySQL on your machine and run the install script, then you're going to be prompted for to set a password. That's going to be the root password, and then you can also set up other user accounts. Since we don't have that startup script, we're not installing MySQL and running a script, we're automating the whole process. We're going to set that password using an environment variable. And then we also want to set up a username and password. Now there are a few things, part of why this took so long yesterday, just a few snags using Docker Compose with MySQL. I'd like to share my my headaches with you, so hopefully you don't go through the same things. I want you to avoid these things that I went through. The big one that caught me off guard, because sometimes it works and sometimes it doesn't, so I had to figure out why. These environment variables are only read when the container is created for the first time. So MySQL, when MySQL runs and installs and gets all set up for the first time, it's looking for these environment variables. If these environment variables are set, it's going to read those variables and set all the values appropriately inside MySQL itself. If you shut down MySQL, shut down the container and everything, and then restart that container, MySQL will not look at these variables again. These variables that does not change inside the container. So if I wanted to change this password right now and change it to the very strong password, change me to, well, my app is going to read this new environment variable. MySQL will not. So the password in MySQL is still change me. My app is using the password change me to, and it's going to continuously say, which will haunt me for a while, this user is not authorized to access this database or whatever. Apparently it isn't haunting me because I already forgot the wording of the error message. But MySQL will deny you access to the database, which I gained a bit of an appreciation. I feel like every time I work with MySQL, I gain a bit of appreciation for this. Is the attackers who can compromise a MySQL database. Personally, I find that rather impressive because I usually struggle to access my own MySQL database. People are out there accessing other people's databases and injecting stuff in them. It's pretty impressive the way there's so many little things that can trip you up in a MySQL database. Maybe it's just me. Maybe I just have bad luck with MySQL. But with MongoDB, I don't seem to have the same kind of headaches that I do every time I use MySQL. Can you delete and rebuild the container? Yes. So I'll go back into this file. But what you do is docker ps, take a look at all of your containers that are running. Go to that MySQL container. Make sure you have the right one if you have two running like I have. Find that container and do docker. Ooh, I actually forgot what it was now. Is it kill? No, rm. Docker rm, and then that container ID, which apparently I didn't copy because I'm on my other keyboard. You'll probably have to shut down that container first. So if we stop that container and then run it. So for example, even if that MySQL container doesn't show up in this list, if you do docker ps-a, that's going to show all of your containers, even the ones that are not running. So even if that container stopped, Docker is still going to spin up that stopped container, and those environment variables won't be read again. So find the stopped container after you stop it, get that container ID, rm it, and then you'll be able to get rid of that thing. Then the container's gone, and it'll rebuild. It'll read those variable names again. So if you change these, the big thing that I did is I was going to use a root password, which is the next, and then just password and hardcode root into my code. That's how I was set up, and I was going to do it that way. That does not work well with Docker Compose. So MySQL does not allow remote access for the root account. And since we're running in two separate containers, MySQL sees that as a remote connection. So you cannot use the root username and password to access a database when you're using Docker Compose like this. The difference between the root password and database password, the root password is for the root user. So actually I could change this and not break my app. even if I restarted the container. I'm not using this root password at all for my app. So this could be anything. And I'm setting up a username named SQL user with a password of change me for this app, and that's the user I'm using to access the app. These are all set in the MySQL container. So this is me telling MySQL, hey, I'm going to have a user with this name and this password. If somebody presents you this username and password, let them in, let them access the database. In my app container where I'm running my app, I'm setting 2 environment variables, just named whatever I felt like naming them, to have that same username and password. Now inside my app, I'm reading these environment variables inside my app container, getting this username and password, and then sending those to MySQL to be able to authenticate and start using the database. So we have 3 different password variables, but they're all very important. Well, the root password, not as important. This I could set to some random string for added security since I'm not using it. I don't want anyone else to use it either. Reading in my code. Mongo injection looks like this. Greater than 0. I mean, would that work? I don't know if that's, I mean, maybe it's a joke or not that I'm not getting, but greater than equal to, I don't know how that would break anything. Even if you could inject that in, I don't understand how that would break anything. Greater than equals 0. So this is setting up inside the find field. It would return all non-negative values, I guess, but so this is going to set up my database and my app. For your purposes, that's what you need, is your database and your app. But I have one interesting thing we'll talk about later, this Nginx part. We'll talk about that. That's actually a topic for 2 weeks from now. We're going to talk about Nginx in Apache and how to what goes into really deploying your app online, getting a domain name, all those kinds of things, getting a signed certificate. Those are all topics for later, but I do want to talk about Nginx itself just a little bit today, just because it's on the screen, but mostly in the context of using Docker Compose and running 3 containers instead of 2. Whoa. So so we'll talk about it in that context, but we'll come back to that. Did you do an example? Oh my goodness, I did examples for Mongo. The last 2 lectures were both Mongo. Going through that, my goodness, I forgot. The image sharing site, that was all Mongo. So go to tictactoe.info. This site was all Mongo. So whenever we were going through this, we had examples of Mongo in the Docker file. Okay, so let's look at I don't know if anybody is. I don't think any teams are doing this, but I do want to show it just in case. This is possibly something that scared people away. But running a web app in Scala or Java, I don't think anybody's using Java or Scala. I don't know if anybody's using a compiled language for that matter. I could be wrong on that. If I'm wrong, let me know. Who's running a compiled language for the project? I know a lot of you are for your homework, but for the project, I think most of you are using Python or Node. I can't think off the top of my head. I have a way to find out. PHP, Nginx, so I guess I can't tell what that one is. Node, Python. Oh, there's a Java. Okay. Can't tell. Node. Another Nginx. Nice. Python, Node, Python, Go. Nice. Flash, Python, entry point, Python, 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 Python. So lots of Python. There's a sprinkling in there, though. 2 compiled languages that I can see, and the Nginxes that I can't. In the Docker entry points that I can't see in the screen. Node.js compile to. Not that I'm aware of, but maybe. Node.js compile to. Does it? I know, like, maybe does it compile in the sense that, like, Python compiles? It might, but we treat it as an interpreted language regardless. So at the very least, what I'm about to talk about doesn't really apply, is that in your Docker file, you have to compile your code, which is something you don't have to do in Node.js. So with with a compiled language, there's a bit more setup that we have to do. Now we could find, and I could have found a container that has Java and Scala pre-installed. I'm sure there's one out there. I decided to just go from Ubuntu here. And when you have is install the language itself. So I have to install both Java and Scala so I can get everything installed. And Scala, just the way it is, takes a lot of lines to do to install Scala and SBT here. With Scala, I want a very specific version of Scala. So I'm going to get that file, that version of Scala specifically from the archives, just to make sure I don't have compatibility issues. Some of my libraries aren't going to play well with 2.13 specifically. So pulling that, installing Scala, installing Maven, which is going to be my package I'm using for package dependency management. This we've seen plenty of times. And I'm going to run Maven to install all my dependencies and also build my project. So this is going to produce a jar containing all of my dependencies. They're all going to be linked together. All of that's going to be in one jar file created through that through Maven. I'm going to wait for my database and then run that jar file. So there's a bit more that goes into this when you're running a compiled language rather than an interpreted language that or setup could be a bit. And POM, personally, I'm really starting to fall out of favor with POM. There's just so much. All I want to do is say, download these dependencies and run the thing. And there's just so much bloat in this thing. But all this says is compile my code, add the dependencies to a jar, and run the main method in this class once you're all done. Once somebody runs this jar, once it's an executable jar. All this to say that. And I only have 4 dependencies here. In Python, this would be a line with 4 file with 4 lines, probably just 4 words total. So a little difference here. A lot more stuff that we have to specify, but it is what it is. I wish it would have a simpler mode to it, at least, for when you don't need the full power of Maven. As the mantra goes, simple things should be simple, complex things should be possible. And Maven just says, no, it can all be complex. I feel like the whole Java ecosystem, to be honest, is a little bit like that. But let's just evidenced by Hello World in Java is pretty bloated. But we're not here to talk about that. Let's compose file. I mentioned these. If you change any of these variables, you have to destroy the container and rebuild that container. That's one of the most important things. You do have to set up a username and password. Excuse me. And let's start talking about Nginx. I think I got the SQL specific stuff down. Found out Node.js doesn't come with linked lists by default. Yeah, I never thought about that, but yeah, I don't know where that would be because it uses arrays as its standard sequential data structure. Linked lists. Yeah, I guess I never looked for it, but it's interesting. So this is actually a solution to a problem that I had with the library I'm using, I guess. But the solution is one of the topics of. Never mind. The solution is one of the topics for a few weeks from now of structuring an entire web app. So we'll at least get a taste of that now. For this, I'm going to run. So in my Scala code, I'm running my Scala code as a WebSocket server. That code is only a WebSocket server. However, I have some. Please curve. I already adjusted the grading. Were you not there? If you're not there, you probably don't. Never mind. But I have a HTML file. I have an HTML file. I have a JavaScript file. And a library that I am hosting just so I don't have issues with the library. I have had issues in the past where getting a library with a URL from another website, if that website goes down or denies that connection for any reason, I've had that happen before. You don't have your library anymore. It's always better to self-host any libraries you need. And then the WebSocket connection. So the WebSocket connection goes to my app, my WebSocket server. But how do I host these files? How do I host those files when my WebSocket server is already blocking the port that I want? I would like to host all these on the same port. But my WebSocket server, that library says, I need this port. This is my most web frameworks have a way to combine WebSockets and their HTTP server, so you can have that service do the routing. So in the Python, oh boy, what did I? So in Python, I used Flask and then a specific library to do socket.io in Flask. This library is written for the Flask framework. That library takes a Flask app. I create this Flask app, and then the socket server wraps around that app. So the socket.io server and the app are connected, and then that library can do the routing and say, is this request meant to be a socket.io, a WebSocket connection, or is it meant for the HTTP server? And there's some routing that happens to be able to decide how this request should be handled, just like we had to do in the homework. Is this request a WebSocket connection? We did it with a little routing. We checked the path, and if the path was for our WebSockets, we can send it up to where it needs to go. So if you don't have a library for your specific framework, for, in my case, socket.io, because the front end is speaking socket.io, or, well, I guess a web framework that has a library that connects to socket.io, or I have to do the connections myself. At some level, this has to be solved. We have to have two different libraries, or one library that has socket.io built in, but, not every web framework development team is going to build socket.io support for this specific library out there. Not everybody's going to do that. A lot of them have WebSocket support, but not specifically socket.io support. So we need some way to handle this. My solution is to use Nginx. We're going to pull in Nginx, an Nginx Docker image, and copy in some files into this image and listen on the good old port 80. We're finally listening on port 80 with some. Nginx is a web server which is going to handle. I use it mostly as a reverse proxy. So when I get a request on port 80 of this server, Nginx is going to decide where to actually send that request. So this server that I have is running this server here with this IP address is running a lot of different apps. So it's running, of course, chat, team 1, why though? Only team 1? Let's... Yeah, should have got this redirect. But it's the same IP address. Not too crazy there. There's the same subdomain. cc312.com. Same server. I have Nginx running and handling that routing at that level. So Nginx is listening on ports 80 and 443, appropriate app. So I have my public directory, and I don't have to go into that. That just has the, you know what, might as well. As my, and I'm not even, after that whole thing, I'm not even hosting Socket.io, the Socket.io library right here. I am for the clicker game, because I knew I did that, but I made a big deal of it too. So I have to set up some configuration for Nginx. So what I'm doing to get around my problem is if I get a request, I'm going to send that request to this directory, and I'm effectively hosting all of my static files in that public directory using this configuration. So I'm saying this directory is going to have all of my data. If you get a request, look in that directory for a file name of that name. And if the request is just /, look for a file named index.html. This is this part right here. This is all standard setup for Nginx. And then in my Docker file, I take everything in that public directory and move it into that directory that Nginx is hosting static files from. And Nginx has some nice caching features too. It is very efficient at hosting static files. So this is much better than hosting static files in whatever web server I'm using. So any static files, it's common to have those set up being hosted through a different server, through a content delivery network, a CDN. Have your static content hosted with a server that's really meant to be very optimized hosting static content, Nginx being one of those. So I'm putting all my files there and just having Nginx host those right on port 80 without getting any other code involved. Nginx is responsible for hosting my static files here. If the request is for the path socket.io, which is the default path for Socket.io connections, if the path is for Socket.io, now proxy that over to port 8080 where my Socket.io app is running on the host app, the host matching what I named my container in the Docker file. So I named that container app. So I want to say if I get a request for the path Socket.io, use that path as a reverse proxy to go to my app container port 8080, forward the WebSocket headers, make sure those headers are going through, and also the IP. I'm not doing anything with this for this example, but I like to always forward the IP address as well, just in case I need it on my server side, for my app, if I want to do something with that server. And then some boilerplate. I didn't get rid of all the standard crap that comes with the default configuration file. All stuff that you can add to this. So now a request comes in on port 80. And there's quite a few parts here. So just to see who's static files, which it's hosting immediately, or it's getting requests on the path socket.io, which is going to forward to my app port 8080, where it's listening for WebSocket connections. It's going to connect that WebSocket and communicate with the user through that WebSocket. And some of those communications require database access if somebody's sending a message. So it's going to access the MySQL container port 3306 and connect to that database and store information in that database. Nginx to the outside world, I'm going to run on port 9000. So my port 80 on this server is my top level Nginx, which is listening for these web connections. When I send this request to chat.cse/software.com, that request is first handled by my top level Nginx that's running on my server. So I can't use port 80. That's used up by a lot of different apps. A lot of apps are using that port. So I'm going to map this kind of arbitrarily to just some for my Nginx is in a subdirectory. So to specify that directory, Docker Compose is going to look in this directory for a Docker file and then build with the Docker file it finds in that directory. Why port 80 and not 443? I'll talk about that in a second too. And you can see that this is, it's encrypted. So we are fine, and I can explain why. Again, in 2 weeks from now, we'll talk about that again, but there's no reason to not talk about it now. So my whole app is listening on port 9000, and we can see that container. That Nginx listening on 9000 is for the chat app. And then level when we go to my top level app, we can see when we get requests for chat.csesoftware.com, I'm going to forward. I'm not even forwarding the IP address here, so I guess forwarding the IP address inside the container doesn't matter. I'm going to forward those requests to port 9000, send any WebSocket connection headers. For some reason, you have to specify, like most headers get forwarded. For some reason, these ones don't unless you specify it specifically. I don't know why, but you have to specify these things. I'm going to forward all those requests to port 9000 whenever I get a request for this domain name with this subdomain. So that way I can get requests and then route them using Nginx to different ports on my localhost. So this is why, so usually only Nginx or Apache, or if you have some obscure third web server that you want to use, those are the only apps that typically listen on ports 80 and 443, and then they decide how to route that traffic from there. It is a typical setup for a web app. So this here, this top level Nginx, this is where we have the encryption. So once a request, so this is encrypted. I have my public and private key installed right here into my Nginx server. It's 80 around here. We don't do that. Forward that to port 443, and then all this configuration handles the 443 request. So nobody can connect without being encrypted. But once we're inside the server, so going from this Nginx to, and follow me here, from this Nginx, which will forward a request to a Docker container running another instance of Nginx, which is going to route that request to either itself and just host the static files, or to my other app in another Docker container, making that WebSocket connection on port 8080 inside that container. All of that communication is happening on the same physical server where nobody can sniff packets. Nobody can monitor that communication unless they already have access to my server if they already have access to my server, I'm worried about a lot of other things, not them reading my my traffic. So all this internal communication on my server itself doesn't have to be encrypted, because who's going to eavesdrop on that? There's just no reason to encrypt that traffic. So all of that traffic can be unencrypted. I can use HTTP here safely because it's internal to my servers. So whenever we're building our apps, whenever you build your apps for your project, you're building your app with, sorry, Team 6. I showed off Team 7 last time a bit, so you're only building an HTTP server, which is common. I never build HTTPS servers really for apps I'm going to deploy, because Nginx is going to handle the encryption for us. Nginx is going to be the public-facing app. That's going to handle encryption, and then once we get that request, we can forward it unencrypted internally on the server. So I have this teammate built an HTTP server with no encryption, but when it's live on the internet, all the communication going over the internet itself, but we don't have to worry about it during development. Yeah, there's no curve, Armani. But I specified, I made a post I talked about in lecture, how the homework grades, that 0 through 3 grading, how that maps to percentages. And I was fairly generous on that, I thought, anyway. But we'll see. So I think that's all I need to talk about here. Does anybody have questions about anything you just saw? Do developers use WS or WSS? WS, for the same reason. Like this, like my code for this app doesn't know anything about encryption at all. Not in the least. But this is still a WSS request, because my Nginx instance has that signed cert installed on it. So I still get WSS, but we don't have to think about that as developers. Okay. Let's oops. Just to show you I'm not going completely crazy. Hosting the library locally here. I don't really think there's anything different in the deployment infrastructure here. A similar setup in terms of the deployment that I just kind of ran through, and we can get a clicker game. This is what this is the current homework in 1.16. They have to build this thing, and I can click and buy equipment. And when I revisit the site, my progress is saved. I don't know how much we really need to talk about in the class, but it uses a database, of course, and gets some features. This also is running these three separate containers: the app, MySQL, and Nginx. How come that image just got a name of MySQL? Man, my line's not lining up. Why are those... I think those image names should have been different. Maybe it's just because these names are different that they don't collide. I feel like these should be Scala Chat MySQL and Clicker Deployment MySQL. I wonder if that's what happened when we first loaded it up, if my MySQL instances were colliding. Oh yeah, that clicker is awesome. It takes a long time, but finally getting some cool assignments. I'm excited. Cool assignments in 1.16, and I'm excited for 3.12 to evolve. I can get some really badass assignments in here. Not that they're I'm happy with them the way they are now, but if I can get a lot more flavor in there. And this clicker game works with a configuration file, so it's a generic clicker game that they can design. They can redesign themselves. But they build the infrastructure for it to read this JSON string and build the whole game based on that configuration. So they can expand it. Once they get sick of this one takes, I don't know, 3 minutes to get to the end game and not really have any fun with it anymore. So if they want a more complex one that takes longer to beat,